Alright, number 6, we have to find the equation of the normal to the curve y equals 2 root x plus 2 at x equals 4. Now, let's pause the video. Alright, now we need to find the y value first, so we'll put 4 into this, and we get y equals 2 root 4 plus 2, and that gives me 2 times 2 plus 2 is 6. Now, clearly we need to differentiate this, but before we do that, we can actually rewrite this as 2x to the half plus 2, and when we differentiate that, the half comes down, and it becomes just 1, and reduce that by 1, we get the other half, and we differentiate the constant, we'll get 0, so that's simply 1 over the square root of x. Now x is 4, so y dash equals 1 over 2. Now this is the gradient of the tangent, so the gradient of the normal is going to be equal to minus 2. So putting this in the form y minus y1, so that's y minus 6 equals the gradient minus 2 outside of x minus 4. Minus 4. And that becomes y minus 6 equals minus 2x plus 8. And putting it in the general form, I get 2x, taking it across the other side, plus y minus 14 equals 0 in the general form of the equation of the normal to this curve. Okay, number 7. We have to differentiate y equals the square root of 4 minus x squared. Again, pause the video. Alrighty, now what you need to do here is rewrite that as 4 minus x squared to the half. This is the case of the chain rule. So what I'll do here, I'll just go y dash equals this half, comes down the front. So that's a half outside of 4 minus x squared. Take a 1 away from that, gives you minus a half. Now look inside of these brackets and differentiate what's inside, and we get minus 2x. And of course, tidying that all up, that becomes simply minus x all over the square root of 4 minus x squared. Alright, in question 8, we have to differentiate this product. Now this is actually a combination of the product rule and the chain rule. So what I'll do here, I'll first of all let u equal x squared plus 1. So we're going to have u equals x squared plus 1, and v equals 2x minus 1 to the fourth. So du equals 2x, and v equals, now the 4 comes down, 2x minus 1, take 1 away, 3, look inside, times 2, so this is really 8 outside of 2x minus 1 all cubed. So our derivative f dash x is equal to, I'll just take this, it's u dv, so it's this one, and I'll write that as 8 2x minus 1 cubed times x squared plus 1 plus, now the other way, it's this one, and that will be 2x outside of 2x minus 1 to the fourth. Now that's pretty messy, so we'll take out the highest common factor. Here we'll see there's a factor of 2 in here, so we'll take the 2 out. And the next highest common factor here will be the 2x minus 1. So that's 2x minus 1 cubed. Okay, so we've got a 4 in here, and then we've got the x squared plus 1, and we've taken out, and we've got x here, and a 2x minus 1. Alright, so it's 2 outside of 2x minus 1 all cubed, and here we'll have a 4x squared and a 2x squared, which gives me a 6x squared, and I'll have a minus x, and I'll have a plus 4. That's my final result. All right, number 9, differentiate function x equals 3x plus 1 over x minus 1. Pausing the video. Okay, now here this is clearly a case of the quotient rule. So my u equals 3x plus 1, and my v equals x minus 1. The u equals 3, the v equals 1. Now f dash x is going to be v du, this one here. So it'll be 3 outside of x minus 1 minus u to v. Now put a bracket around that, 3x plus 1, all over x minus 1 all squared, x minus 1 all squared. Now the 3x's will go out. This is minus 3 minus 1, so you get minus 4 over x minus 1 all squared. Okay, the last one. We have to differentiate x cubed minus 2xy plus y cubed equals 4. Now this is a case of implicit differentiation. If it's not in your course, we'll skip this one, but it is in more advanced levels. So differentiating with respect to x to both sides, we'll get that's d dx of x cubed minus d dx of 2xy plus d dx of y cubed equals d dx of 4. Now d dx of x cubed is 3x squared. Now this one here, we'll take the 2 out the front, and again we'll treat this, that's my u and that's my v, but I'll have a minus 2, put a bracket around that. Now differentiating, holding the u, this x constant, differentiating this one, you'll have, that'll be equal to x dy dx plus, and holding the y constant, y times this one, which is just 1. Now differentiating this one, 3 comes down, reduce it by 1, and then times it by dy dx, and this of course equals 0. Tidying this all up, we're going to have 3x squared minus 2x dy dx minus 2y plus 3y squared dy dx equals 0. Alright, now just rearranging this a bit, we're going to have that 3x squared minus 2y plus, taking out the dy dx as a common factor, of minus 2x there, and you'll have a plus 3y squared there equals 0. Now we'll take this one across the other side, and I'll have dy dx outside of 3y squared minus 2x, just rearranging that a bit, is equal to, now this will be 2y minus 3x squared, and dividing both sides by 3y squared minus 2x, we get dy dx equals 2y minus 3x squared all over 3y squared minus 2x. That's your final result.